In this video, I'm going to explain how to solve this problem using motion and Newton's second law. So let's start by making a complete body diagram. So to do that, let's draw the incline and a flat surface. And here we have a, we are going to indicate that is a 30 degrees incline, and this is our box that is originally at rest and is going to slide down this incline with no friction. So we're going to start to draw the free body diagram on this box. So since it's on incline, we have the components of the weight. We have the weight is straight down, and we have our FGY, that's the vertical component or Y component, and we have our FGX. We have a normal force, but because the problem say this incline is frictionless, no friction, so there is no force that opposes the motion. So Fn is equal Fg, and they cancel each other. Now we need to indicate that this angle is the angle of the incline, and we are going to highlight that is a right triangle, which is going to be handy when we have to calculate the components of this diagram. First question is this: what force accelerates the box down the incline? So the only force acting on the motion as is sliding down is Fgx. So let's calculate Fgx. If you temporarily move down here to this right triangle, Fgx, I'm not duplicating, I'm just moving to calculate the value of the magnitude of Fgx. So Fgx is the opposite of this angle, so I'm using sine. So sine of 30 degrees is opposite Fgx over hypotenuse, which is Fg. So now I'm doing cross multiplication. Fgx is Fg sine of 30. So Fg is mg sine of 30. Okay, so as a result, the mass is 100. G is acceleration of gravity, 9.8 meters per second square, sine of 30 degrees. So plug in the calculator, we have 490. So 490 is the magnitude, 490 is the magnitude of the horizontal component of the weight. B is asking the acceleration of the box. So the acceleration of the box can be easily calculated using Newton's law. So F is equal to ma. So the only force that is acting on this box as is sliding down is Fgx, ma. So here we have A is Fgx over m. So A is 490 divided by the mass in kilos. So my acceleration is 4.9 meters per second square. So C is asking, what is the final velocity of the box at the bottom of the plane? So our VI is 0 because the problem rests. The final velocity is what it's looking for. The distance was given, was 4 meters, so the distance where the box is located to the bottom of the ramp is 4 meters, and acceleration is caused by the horizontal component of the weight and didn't say nothing about time. So we can use our equation, motion equation, VF squared, VI squared plus 2AD. So VF squared, what we're looking for, this is 0. 2 times 4.9 times the distance is 4. So VF squared is 39.2. And when we square root this, my VF is 6.26 meters per second. So the box is going to hit the bottom of the plane with that speed. So letter D is asking what is the initial velocity of the box as it begins to slide along the floor. The box is gonna be right here now. So it's coming down from the ramp. Now it's right here on the flat surface. So what is the initial velocity of this box as it starts to slide on this flat surface? So it's very easy to observe that the transition from ramp to flat, the initial velocity will be exactly the final velocity from this ramp. So the initial velocity is equal to the same final velocity when the box hit the bottom of the ramp. E. What force slows the box down? So this is our free body diagram when the box is on a flat surface. We have four forces acting. We have the weight, we have the normal force, we have the friction force, and we have the component of the weight that is actually acting on this box as is sliding on the surface now. Okay, however, this surface has a friction. So the friction, the coefficient of friction of this between the surface and the bottom of this box is 0.2. So the question E is asking what force slows the box down. So that will be our friction force. So we are going to calculate this friction force. Let's do E right here. So E, let's find friction force. So the formula for friction force, let me do here a little box. Friction force is mu Fn. Mu is the coefficient of friction, Fn is the normal force. So we don't have Fn, but we know how much is Fg. So Fg is equal to Fn. So here we have F is 0.2 and Fn is our mg. M is 100 and g is 9.8. So our FF is, when you multiply all these, we have 196 newtons. And here Fn is equal Fg. And Fg is mass times acceleration. Question F. What is the deceleration of the box? So we have here the box is decelerating because now we have a friction force acting against this motion. So it's going to decelerate up to stop. So here we have an F net acting on this motion, which is just this on this direction. So we have Fgx minus Ff. So that's our F net. Now remember that F net, let me continue here a little bit to answer question F. So our F net is equal ma. But there are two forces acting on this box, which is Fgx minus Ff is equal to ma. So our FGX is 490. Our FF is 196. M is 100. And this is our acceleration. So A is equal 490 minus 196 divided by 100 is 2.94 meters per second square. So that is our deceleration on the flat portion of this trajectory. Now the last one is asking how far does the box slide before come to rest. So let's use this space. How far? So it's asking for distance. So we are going to, on G, let's answer my G here. We have, let's do our data table. VI, VF, DAT. So how far does the box, so it's asking for D, before coming to a rest? So the final velocity is 0. The initial velocity is 6.26 meters per second. Our deceleration is 2.94 meters per second square. And didn't say nothing about time. Okay, so now the equation that we can use to calculate this is, now we can use the motion equation. VF squared is equal to VI squared plus 2AD. So our VF squared is 0. VI is 6.26 squared plus 2 times 9.94. 2 times 2.94 D. So then we have our D is 6.26 square. So here we have 0.39.18 plus 2 times 2.94 is 5.88 D. Now notice this is a deceleration, so we are going to make this negative. So we are going to change our plus sign with negative acceleration. So now we have 39.18 is equal 4.88 D. So divide both terms by 5.88. So our distance is 39.18 divided by 5.88. 6.6 meters. So that's how far the box went due to the deceleration of the provided by the surface.